A great day to one and all. I am Kim J.C. Ensho, and today I will be discussing with you Licensure Examination for Teachers Preparation for Mathematics Majors Set 4. I hope you have your pens and your paper with you. I hope you will join me in solving these problems. Feel free to pause the video from time to time, and let's see if you got the correct answer. I hope you're ready. So for the directions of this, write the letter of the correct answer before the number. If the correct answer is not found among the choices, write E. I have the presumption that you have the PDF copy of the presentation with you. So I hope you are with me. Let's begin with item number 1. A group G is said to be an abelian if it satisfies blank. Is it commutativity, associativity, closure, or distributive property? What do you think? So this one is in abstract algebra. And when we speak about a group, a certain set under a certain operation is said to be a group if it satisfies 4 properties, namely closure property, associativity, existence of an identity element, and the existence of an inverse for every element in that particular set. But aside from that, a certain group G is said to be abelian if it is commutative. Letter A. So when we speak about commutativity, if you have any 2 elements A and B and a certain operation, say star, then A star B is the same as a B star A. I hope you got it correctly. Like the set of natural numbers, the set of integers under addition, it's actually an abelian group. Because it's, aside from the fact that it's a group, it also satisfies commutativity. Letter A. Number 2. The 2 arithmetic means between 49 and 76 are, is it 58 and 67, 54 and 59, 55 and 64, or 58 and 64? Which of these do you think is correct? For this one, since there are 2, we are looking for 2 arithmetic means between them. So it turns out that 49 is the first term and 76 is the 4th term. So we're going to look for the values of the 2nd and the 3rd term. So from here, it's known that the first term is 49 and the 4th term is 76. And I hope we are familiar with the terms or with the nth term of an arithmetic sequence. That is a sub n equals a sub 1 plus n minus 1 times t. So from here, the 4th term could be expressed as the first term plus 3 times the common difference. But since the 4th term is 76, so that's why a sub 1 plus 3d is equal to 76. But we see that the first term here is 49. So we will substitute this first term, or a sub 1, with 49. And you will have 49 plus 3d equals 76. Subtracting both sides by 49, you will have 3d equals 76 minus 49, which is 27. And to solve for the value of your common difference, we will divide both sides by 3. And hence you get d equals 9. So therefore your common difference is 9. And if you will be working from left to right, to get the next term, all you have to do is add this common difference. So 49 plus 9 will be 58. 58 plus 9 again will be 67. And if you wish to continue the pattern, 67 plus 9, you will get 76. So see, it satisfies this. With such, the correct answer is A, 58 and 67. Number 3. Which of these pair of sequences is the reciprocal of each other? Which of A, B, C, or D do you think? So always remember this. This is in fact one of the properties or some things that we know. Harmonic and Fibonacci are not reciprocals of each other. Arithmetic and geometric are not, but arithmetic and harmonic is. That's why the correct answer here is letter C. We have to remember that if you are given a certain arithmetic sequence, then to get its corresponding harmonic sequence, then all you have to do is find the reciprocal of each term of your arithmetic sequence. But again, hoping that no term is undefined. Okay. Number 4. Consider a sequence with a sub 1 equals a sub 2, which is 1. And in which a sub n is equal to a sub n minus 1 plus a sub n minus 2. What is a sub 8? Is it 20, 21, 22, or 23? What do you think? So from here, if you are just keen enough, you will actually realize that this is in fact the definition of your Fibonacci sequence. So that's why if you have 1 plus 1, then to get the third term, you have to add the second and the first and the second. So 1 plus 1, 2. To get the fourth, you have to add the second and the third term. So 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8. 5 plus 8, 13. 8 plus 13, 21. 13 plus 21, 34, and so on. But we are looking for the eighth term. And you could see from the left, we have 1, 2, 3, 4, 5, 6, 7, 8. So the eighth term is 21, letter B. Okay. Number 5. Let P of A denote the power set of A. If P of A is a subset of B, then which of these is correct? Is it 2 raised to this one? The cardinality of A is less than or equal to B, the cardinality of B. Take note, this absolute value symbol is read as cardinality for sets here. Is it B, C, or D? What do you think? So we have to remember this. When we speak about power set of A, it means the set of all subsets of A. And in fact, it's a theorem in set theory that the number of subsets of a certain set, denoted by the power set of A, is equal to 2 raised to the cardinality of set A. Meaning to say, like how many elements? 2 raised to the number of elements of set A. But since this one is the given, so we will replace P of A with 2 raised to the cardinality of A. And of course, this one, it's a subset of B. So there is a presumption that this one has a cardinality which is less than or equal to the cardinality of set B. Hence, letter A is the correct answer. Number 6. Consider the elements of Z sub 4, meaning to say it's a set of all integers that are remainders when you divide a number by 4. So if you divide the number by 4, the remainders are either 0, 1, 2, and 3. How many generators does Z sub 4 under operation addition modulo 4 have? Are there 2 generators, 3, 4, or 5 generators? What do you think? So from here, when we speak about generator, it should be able to generate or upon operation or operating 2 itself, we should be able to generate all the terms or all the elements of your z sub 4. So let's try 0. If you have 0, 0 plus 0 will be 0. So no matter how many times you add 0 to itself, you will still get 0. If you have 1, 1. That's the first term. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 0. So you might ask, sir, how come 0? 3 plus 1 is 4, right? But if you divide that by 4, 4 divided by 4 gives a remainder of 0. That's why it should be 0 here. If you have 2, so you write 2 itself. 2 plus 2, 4. But when 4 is divided by 4, the remainder is 0. 0 plus 2, it will go back to 2. So if you keep on repeating this process over and over again, it will just become 2, 0, 2, 0, 2, 0, and so on. So it will just generate 2 and 0. But if you have 3, the first number is 3. 3 plus 3, that's 6. But 6 divided by 4, that's 1 remainder, 2. That's why I have here 2. 2 plus 3 will be 5. If you divide 5 by 4, the remainder is 1. So we have 1 here. 1 plus 3 will be 4. But 4 divided by 4 will give you a remainder of 0. 0 plus 3, you will go back to 3. So it just repeats 3, 2, 1, 0, 3, 2, 1, 0, and so on. If you could see, 1 and 3 could generate all of the terms of z sub 4 here. And by the way, order here is not important as long as the elements are present. Hence, there are only 2 generators. So, in this case, those generators are 1 and 3. Hence, letter A is the correct answer. Number 7. Given the formula, A sub n equals 2 times of A sub n minus 1 plus A sub n minus 2 with A sub 1 equals 3 and A sub 2 equals 5. Find the value of A sub 4. So you will have 25, 27, 28, or 31. You have A sub 1, you have A sub 2. So to get the value of A sub 4, it's important that you get the value first of A sub 3. So from here, we will replace the n with 3. If you replace n with 3, it will become twice of A sub 3 minus 1 or twice of A sub 2 plus A sub 3 minus 2 or A sub 1. And you could see that A sub 2 is 5 here based on the given and A sub 1 is 3. So by substitution, it will become A sub 3 equals 2 times 5 plus the value of A sub 1, which is 3. 2 times 5 is 10 plus 3. That gives you A sub 3 equals 13. Now that we have the value of A sub 3, we can now determine the value of A sub 4 by replacing the n with 4. So if I replace all n's with 4, it will become A sub 4 equals 2 times A sub 4 minus 1 or A sub 3 plus A sub 4 minus 2, which is 2. That's why you have it A sub 4 equals 2A sub 3 plus A sub 2. What's the value of A sub 3? It's 13. What's the value of A sub 2? It is 5. So by substitution, you will have A sub 4 equals 2 times 13 plus 5. That's 26 plus 5, which is 31. So if you answer D, you got it right. Okay. So far, I hope you are doing good. Number 8. Consider the arithmetic sequence 5, 2, -1, -4, and so on. Find A sub 11. Is it -22, -25, -28, or -31? When we speak about arithmetic sequence, like you are adding a constant term known as a common difference to achieve the succeeding terms, like this one. Here, 5 plus -3, it's 2. 2 plus -3, it's -1. -1 plus -3, it's -4, and so on. So the first term here is 5, and the common difference is -3. And since we are looking for a sub 11, then the subscript here 11 will serve as our n. So with such, I hope you could remember the formula. That's a sub n equals a sub 1 plus n minus 1 times d. So replacing n's with 11, so we have the first term as 5 and d as -3. We arrive to the equation a sub 11 equals 5 plus 11 minus 1 multiplied by -3. Everything was copied. It's just that 11 minus 1 was simplified to 10. That's why you have a sub 11 equals 5 plus the product of 10 and -3, which becomes 5 plus -30. And if you simplify that, that's equal to -25. I hope you answered B and that you got it correctly. Number 9. Given the arithmetic sequence with a sub 1 equals -10 and a sub 5 equals 2, find a sub 14. Is it 29, 30, 31, or 32? So using still the same arithmetic sequence formula, we could actually determine the value of the common difference. So using this formula for arithmetic sequence, I will substitute n with 5 because that's the other given. That's a sub 5 equals a sub 1 plus 5 minus 1 times d. That's a sub 5 equals a sub 1 plus 4d. In this case, I just replace all n's with 5 and simplify the results. So what's next? Remember that the a sub 5 is 2. The a sub 1 is -10 based on the given. So adding 10 both sides, the left side will become 12 and the right side is 4d. Dividing both sides by 4, you will get the value of d, which is 3. And since we have now the value of d, we can now determine the value of the 14th term. So the same thing, so n will be replaced by 14. So we have a sub 14 equals the first term, which is -10 plus 14 minus 1 multiplied with the common difference, which is 3. So it will become the rest, everything was copied. I just expressed 14 minus 1 as 13. 13 times 3 is 39. And hence, the sum of -10 and 39 is 29, which means the 14th term of the sequence is 29. Letter A. 10. Which term of the sequence is 13, 6, -1, and so on is -85? Is it 13, 14, 15, or 16? We don't know. What we know here is that 13 is the first term. If you get the common difference, so you see that 6 minus 13, it's -7. -1 minus 6 is -7. So that's your common difference of -7. We don't know what term is -85. So we will solve for n first. So that's why I replaced the last term here. Let's assume that it's the last term. It's -80, or our specific term that we're looking for, by the way. So we have -85 equals the first term 13 plus n minus 1 times d, which is -7. Next, I subtracted both sides by 13, and the rest were just copied here. -85 minus 13 is negative 98. And that's equal to the product of n minus 1 and negative 7. Dividing both sides by negative 7, negative 98 divided by negative 7 will be for positive 14 because negative divided by negative is positive, equals n minus 1 on the right-hand side. But we're looking only for n. So plus 1 both sides, you got 15 equals n. And this tells us that negative 85 is the 15th term, or a sub 15 is negative 85. So the answer here is 15, letter C. I hope you got this correctly, my friends.